Okay, for this experiment, which is the Lab 11 Stoichiometry and a participation reaction, I've already read through, I've already done most of the math because these videos have been like 30 minutes long and I wanted to not do that. So I've already kind of went through, kind of read to know what is going on, so it won't hopefully take me near as long to do so. So now it says review the following reaction where sodium carbonate and calcium chloride dihydrate react in aqueous solution to create calcium carbonate solid participant formed in the reaction, a salt and water. So put on safety goggles, okay, and upside down. Okay. All right. Okay. So we're going to use this graduated cylinder of 25 milliliters, and we are going to measure 25 milliliters of distilled water. Okay, so that's 25 milliliters. Okay, and there's 2 beakers apparently. So this is 25 milliliters of distilled water, and then we're going to do another 25. Okay, so that's 25 milliliters. So in each of the little 100 milliliter beakers, there's 25 milliliters of that. Okay, and it says turn on the digital scale and place the plastic weigh boat on the scale and tire the scale so that it reaches 0. So there's the little weigh boat. It's going to be 0. So then we're going to put on our gloves and we're going to measure 1.50 grams of the CaCl2 to H2O, which is going to be this little guy, calcium chloride. Okay, and we're going to use a little metal spatula. And we just want 1.50 grams. So let's get 1.50 grams on here. Okay, so let me take some out because we're at like 5.8. 5.4, 5.2, 5.0, 1.50. Okay, so carefully add the calcium chloride to one of the beakers containing 25 milliliters of distilled water. Okay, so we're going to pick this little guy here. Okay, so it says submerge the weigh boat into the beaker to transfer all of it. So first we're going to pour it on in there. And then we're just going to submerge it in there just to get all of it off, right? Yep, all of it. Okay. And if any residue remains in the weigh boat, swirl the beaker until it is fully dissolved into the water. So it doesn't look like any's left on here. And we're just gonna, so I guess we could swirl it around just because it's gonna dissolve anyways, right? Okay. So we're gonna swirl that around. Okay, rinse the weigh boat and metal spatula with distilled water and fully dry both. Okay, so this is going to be my distilled water. I'm just going to rinse it. Okay, and then I've got these paper towels here that I'm going to use to dry it, to fully dry it. So that is rinsed and fully dried. This here, rinsed, and we're going to fully dry it. Okay, fully dried. Okay. Alright, so use the information and examples provided in the exploration to calculate how many moles of calcium chloride are present in 1.50 grams of calcium chloride. And then calculate how many moles of pure calcium chloride are present in the 1.50 grams of calcium chloride. So I've already done this. That way my video is a lot shorter. So I'm going to see. And let's see here. So, these are pretty much my calculations. So I did the molar mass, and then I got 1.50 divided by the molar mass, which gave me 0.0102. And this thing wants to not focus. Okay, and I kind of did that. So then I kind of wrote on the back a little chart here, and I wrote the number next to it to see kind of what was what. Okay, so then set that back up and we can proceed, because that part's already done, which saved us a whole lot of minutes. Okay. Alright, so that was number 8. Turn on the digital scale, place a plastic weigh boat on the scale and tear it so that it reads 0 grams again. So, 0 grams. Okay. Use the metal spatula to measure the calculated amount of sodium carbonate. And carefully add it to the 25 million. Okay. So we figured that it was going to take 1.08. Okay, so let's see, where's my middle spatula? So we had figured it, or I had figured it was going to take 1.08. So we're just going to measure. Oh, too much. Okay, 1.11. Oh, it's about 1.09. Just a hair more. Okay. 1.08. Perfect. Okay. And Na2CO3 are necessary to reach. Okay, so that was number 9. Yep. Okay. And then calculate the amount of Na2CO3 and carefully add it to the other one. So there's this one. We're going to carefully add it to the other one. Submerge the weigh boat into the beaker and transfer all. Okay, if any is left. I don't see any left on here, so I'm not going to submerge it because there's none left. So we're going to stir. Use the stir rod to break apart any clumps until it's fully dissolved. So we're just going to keep stirring. We're going to pour the solution into the other solution. Rinse the beaker containing Na2CO3 with 2 to 3 milliliters of distilled water and transfer the rinse to the beaker. Okay, so this is fully dissolved. I don't see any other particles floating around. Okay, so we're going to pour it into this one. Pour it in there. It makes a nice, lovely looking thing here. Okay, and then we're going to do the 2 to 3. Okay, 2 to 3 milliliters. We're going to kind of stir it around, and then we're going to pour it just to make sure we got it all in there. Okay. All right, and transfer the rinse to the beaker containing. Swirl the beaker to fully mix the 2 solutions. So we're going to swirl it, fully mix the 2 solutions, and the precipitate of calcium carbonate will form instantly. So that's this little bubbles here. Okay. Use the information and examples provided in the explanation to determine the maximum theoretical amount of CO2 CaCO3 in grams that can be produced. So mine was 1.02 is what I had gotten to be the theoretical amount. So we're going to wash the now empty 100 milliliter glass beaker with soap and water. Rinse the beaker with distilled water and thoroughly dry with a paper towel. So let me go do that. And here's the precipitate that formed. Alright, now fold around filter paper into a cone shape as shown in figure 3. So we've already weighed this. And it was, well, I did weigh it. Let's see. What did I weigh it? Oh, I weighed it on the report. Let's see. So when I had weighed it before, I just wanted to kind of get a little starting point. Okay, so the filter paper before was 1.12. Okay, 1.12. All right, so now we're going to fold it in half, and then we're going to fold it over this way. And then I think we just open it maybe. I'm not really sure. I'm terrible at this kind of stuff. So maybe like this. Okay, that's what it shows. All right. Place the folded paper onto the hard square and record the mass of the filter paper. Just did that. Place the folded filter paper into the funnel and dampen it with a small amount of distilled water. Okay, we're going to place it in the funnel like so. And then we're just going to dampen it. A little bit of, let's get a little bit of water in here. Okay. We're just going to dampen it. With a little bit of water. Okay. Okay, it has been dampened. Okay. Okay. Swirl the contents of the beaker to dislodge any precipitate from the sides while holding the filter paper open. Pour the contents of the beaker. Okay. Swirl to dislodge anything. Okay, we're going to slowly pour it into this funnel here. Guessing we're going to have it over this. Okay. Now we don't want to overfill it. And gently swirl the funnel to keep the participant from clogging the paper. Okay, this is going to be the long part. Take 10 to 15 minutes. And then we're going to remove the filter paper from the funnel and place it on the paper towels in a warm location such as a window overnight. So this is basically, I'm going to finish doing this by just swirling around and not overflowing it. But I don't want this video to take 5 years. So that is it. I will put it in a warm location tonight and check back on it tomorrow.